In 2025, a team of scientists confirmed something that had been suspected for years. Megalodon was not the size we thought it was. It was bigger. And the proof came from a single fossil. One that had been sitting in a museum storage box, mislabeled and forgotten, for nearly 4 decades. That fossil put a new number concerning Megalodon's actual size on the table, and it's a significant change. One that no study had been able to confirm before. Here is what we now know, and how we got there. The specimen in question is a vertebra, first pulled from a clay pit in the city Gram in Denmark in the late 1970s. Shortly after scientists took a first look at it, it was moved out of the research lab and vanished from the record entirely. For decades, all that remained were a handful of old photographs. But then, in the late 2010s, staff at the Geological Museum of Copenhagen found it again, sitting undamaged in an uncatalogued storage box. Kenshu Shimada, a paleobiologist at DePaul University in Chicago, led the team that recently analysed it again. And the results were astonishing. The vertebra measured just over 9 inches in diameter. That is the largest fossilized shark vertebra ever recorded, anywhere in the fossil record. Based on that, we now know that this specific Megalodon individual reached a length of approximately 80 feet instead of 60, as we assumed so far. For comparison, a standard city bus is around 40 feet long. This shark was 2 of those, end to end, and it weighed an estimated 94 tons. Think of the hundreds of thousands, maybe even millions of megalodons that ever ruled the ocean, and eventually died. We only found a handful of them so far. So maybe we now just discovered the average size and length, and the largest individuals are yet to be discovered. But the size was only the beginning of what this fossil revealed. By the way, new discoveries and confirmations like this happen more often than most people realize. Wild Sparks has got you covered with other prehistoric giants that forced us to completely rewrite what we thought we knew. Shimada's team also examined the vertebra's internal structure. Like the rings inside a tree trunk, shark vertebrae record annual growth bands. X-rays of this specimen revealed something that stopped the room. This individual was at least 64 years old when it died. That means that the largest fossilized shark vertebra ever found belonged to an animal that had been alive for more than 6 decades. But it was still growing, and still adding mass to a body that had already reached a length no other fish in Earth's history has matched. To put that lifespan in context, Megalodon was not a brief evolutionary experiment. It ruled warm coastal seas for roughly 13 million years, appearing around 23 million years ago and vanishing approximately 3.6 million years ago. During that time, it thrived across virtually every ocean on Earth, from the coastlines of North America and Western Europe to waters as far as what today is New Zealand. Fossil sites on every continent except Antarctica carry its teeth. Why do you think that is? Leave your explanation in the comments section. That kind of territorial range does not belong to an animal that was struggling. It belongs to one that had found a formula and stuck with it for an almost incomprehensible stretch of time. But here's the trickiest part that keeps paleontology struggling. Sharks do not have skeletal structures made of calcified tissue. Their frames are built almost entirely from cartilage, the same flexible material that gives shape to the human ear and nose. Cartilage does not fossilize. When a shark dies, its body breaks down fast. What remains, in the best case, is a small number of partially calcified vertebrae and, in far greater quantities, fossilized teeth. And Megalodon had plenty of them. Most jaw reproductions in museums show only 2 to 3 rows of teeth, which is incorrect. In reality, Megalodon carried 5 rows. At any given moment, there were an estimated 276 teeth arranged, continuously replacing worn ones throughout its life. Over a single lifetime, that adds up to roughly 40,000 teeth shed into the ocean. That is why Megalodon teeth are among the easiest fossils to find, even for private collectors. The richest recovery sites run along the US East Coast, particularly around Florida's Peace River and South Carolina's Cooper River. Fossilized teeth, however, tell us very little about body shape. For that, scientists need vertebrae, and intact vertebral columns are extraordinarily rare. The Danish specimen is among the most significant ever recovered, which is exactly why its rediscovery changed the estimates. The size question is only part of what is being renegotiated. The shape of Megalodon has also come under serious revision. For most of the 20th century, the working assumption was straightforward. Take a great white, scale it up, and you have Megalodon. That model persisted partly because first, great whites are well understood. Second, because they belong to the same broad group of sharks, the lamniforms. And third, because no complete Megalodon specimen existed to contradict it. There is also a common misconception worth addressing here. The great white is not Megalodon's descendant. The two evolved from entirely separate lineages. Megalodon belonged to a group called the megatooth sharks, a line that ended with its extinction. The great white descended from broad-toothed mako sharks, meaning these two are distant relatives at best. The resemblance is convergent evolution. Back to the shape correction. Another 2024 study, also led by Shimada, challenged the scale-up assumption directly. His team concluded that the proportions simply do not match a scaled-up great white. The vertebral column was too elongated and too narrow to support a barrel-shaped body of that mass, even accounting for the buoyancy of water. And so the revised shape model is much leaner and longer, closer in profile to an oversized mako or lemon shark than to the wide, blunt-nosed silhouette most people know from illustrations and film. That revised body plan also produced a revised speed estimate. Megalodon's cruising speed was somewhere between 1 and 2 miles per hour. But not every researcher in the field has accepted the leaner model. Some still defend a bulkier reconstruction, so the debate has not been settled. What is clear from the combined weight of these studies is this. The version of Megalodon that circulated through textbooks and popular culture for decades was built on incomplete data and a convenient shortcut. The real animal, as the fossil record is now beginning to show, was longer, leaner, older, and considerably heavier than previously understood. The Danish vertebra alone will likely anchor Megalodon size estimates for years to come. Whether future discoveries push that ceiling higher remains an open question. The fossil record for this animal is still thin. Every new find has the potential to revise the picture again.